Here we're going to look at a bunch of different examples, refreshing our ideas on the rules of exponents and how to simplify integer exponents and rational exponents. So for this first example, notice I have a bunch of stuff inside my parentheses, but I'm raising it to the third power. So what that says we're doing here is we are doing what's called power to a power. And so when we do power to a power, what that says is that your exponent on the outside gets multiplied by the exponents on the inside. Okay, so the first thing we're doing here is power to a power. So we're going to change this first parenthesis to say -3 to the third. And then we're going to have q to the fourth to the third. And we're going to have r squared to the third. So we're applying it to each part. In this second parenthesis, we're doing the same thing. It's still power to a power. So here we're going to have 2 squared, and we're going to have q squared squared. So power to a power says, again, multiply your powers. So in this first one, we're going to have -3 squared, or -3 cubed. So -3 times -3 times -3 is a -27. And then we're going to have q to the 4 times 3. So this is q to the 12, because 4 times 3 is 12. And then we're going to have r to the 6. 2 times 3 is 6. Then here we're going to have 2 squared is 4. And we're going to have q to the 4. Because 2 times 2 is 4. We have to combine our terms, so we've got this -27 times 4 here. So this is going to be -108. And then I have q to the 12 and q to the 4. So what I have right here between my q's, this would be your product rule. Now the product rule says to add your powers. And then we have r to the 6th. So here I have to use my product rule before I can finish. So this would be -108. Q 12 plus 4 is 16. R to the 6th. Now since everything has been simplified and combined, we have completed our problem. So let's go ahead and let's take a look at another one. So again, the first thing I have to do here is I have to look at what we have. And this 3 right here says that we are going to do power to a power. And the same with this one down here on the bottom. This one is also power to a power. So I have to apply that first before I do anything else. So I'm going to apply it. So this is going to be c squared to my third, and then d to the third. And then on the bottom, I'm going to have c raised to the third, and I'm going to have d squared to the third. So my power rule says that you multiply, so this is going to become c to the 6th, d to the third, all over c to the third, d to the 6th. Now this division line, or this fraction line here, is going to say that we have what some like to call the division rule, better known as quotient. And the quotient rule says that you have to subtract your powers. Well, with that, I like to say when we're doing this, what you want to do is you want to subtract down to the bigger power. So what you want to do here is you want to subtract your larger power minus the smaller power. And then you're going to move the result to your location of the larger power. So in other words, if you have bigger on the top, you're going to move it to the top. If you're bigger on the bottom, you're going to move it to the bottom. So what we're looking at here is we are looking at taking my C term and moving that one up, but then my D term over here and moving this one down. So what we're going to have is we are going to have C to the 6 minus 3 all over D to the 6 minus 3. So in this case, you're going to end up with C to the third over D to the third. Alright, let's take a look at this one. So again, the name of the game is Unpacking Your Exponents. And so here the first thing that we have is I have this little 2 right here, which is going to be our power to the power. So this first fraction over here I'm going to leave alone. This is going to stay u to the 4th over v. And I'm going to multiply this, so on the top this is going to become v to the 2 times 2 over u to the 3 times 2. So power to the power again means multiply. So this here is going to become u to the 4th, v to the 4th, all over v, u to the 6th. So now again, if we look, we've got this quotient line. So this here again says that we have that quotient rule. And again, we are going to subtract to the bigger exponent. So when we look at our u's, my top is u to the 4th, the denominator or bottom is u to the 6th, u to the 6th is bigger. So that says that my u to the 4th is going to move down. However, on the other side, we have v to the 4th and v. My v to the 4th is bigger, which says my v has to move up. So what we're actually going to get here is we're going to get v to the 4 minus 1 over u to the 6 minus 4. So this is going to simplify down v to the 3rd all over u squared, or u to the 2nd. Alright, let's continue making these a little bit more complicated, and let's look at what we have going on in this one. So first and foremost, one thing that we have going on is we have this power of 0. So we need to remember that this is called your 0 rule. And your 0 rule essentially says anything to the 0 is equal to 1. And so what I would do to start off with is apply my 0 rule, which says that I'm going to have 2a to the negative 4b all over a squared b to the negative 3. And then of course this is times 1, which we don't necessarily have to write. Now the next thing that we have is we have this negative power here, so this is called the negative rule. And same with this negative 3, this is also the negative rule. So the negative rule essentially says that you need to flip it. What that means is you're going to change it. So in other words, if you are negative, in the top, then flip to the bottom to be positive. And vice versa. If you're negative on the bottom, you will flip it to the top. So what exactly does that mean? Well, it means that my a to the fourth is going to move down and my b to the negative third is going to move up. So this is really going to become 2b to the third all over a squared a to the fourth. Now, in looking, say, at my a's and at my b's, this is going to be the product rule, both top and bottom. So this is also the product rule. Again, remember the product rule says that you have to add the powers. So here we're going to end up with 2b to the fourth, because 3 plus 1 is 4. And this whole thing is going to be over a to the sixth. 4 plus 2 is 6. Now, yes, I have this quotient rule right here, but if you notice, I only have an a and a b. There is nothing in common there, so I must leave it as the fraction. I cannot combine it any further. Alright, let's look at this next one. So, in looking at the next one, the first one that you should notice is this -2 right here. And this -2 has two rules attached to it. The first rule is the negative rule, and it is also power to a power. So there's a couple ways that you could attack this. The first thing that you could do is you could apply power to a power and then apply the negative rule, or apply the negative rule first and then add power to a power. The fastest way, or the easiest thing to do, is to do your negative rule first, because all your negative rule entails is flipping it, and when we're dealing with a fraction, what that just simply means is flip this reciprocal and change that to a positive. So when we apply the negative rule, this is going to become z over x squared y to the negative first squared. And then we're going to multiply that by that x squared y squared over z to the -3. Okay. So the first thing we did with this first one is we applied that negative rule. So now we need to apply the power to a power rule. So the power to a power rule says that we're going to take it and we're going to put the 2 inside. So this is going to become z squared. On the bottom, we're going to have x to the 2 times 2, and we're going to have y to the -1 times 2. And we are multiplying this by the other side, which is x squared y squared over z to the -3. So what we're going to get here is we are going to get z squared over x to the 4th y to the -2, and again we're going to multiply it. Here what we can do to speed things along is right here we have that negative rule, which says we need to move it. So this becomes x squared y squared z cubed. Okay. Now with that, we've got this -2 right here, which is also my negative rule. So if we flip my negative rule, you're going to end up with z squared and then y squared over x to the 4th and we are multiplying this by x squared, y squared, z cubed. So if you look here, this is now going to be our product rule. So we're going to multiply everything straight across. So this is going to become z squared, y squared, x squared, y squared, z cubed, and the whole thing is over x to the fourth. So I have z squared times z cubed. The product rule says that we have to add the powers. 2 plus 3 is going to give you 5, so this is going to become z to the fifth. I have a y squared and a y squared. Again, add the powers and we get y to the fourth. And then I have an x squared, and the whole thing is over x to the fourth. If we look right here, I have a quotient rule. My 4 is bigger on the bottom, so I have to subtract to the bottom. So what that actually means is I'm going to end up with z to the fifth, y to the fourth, all over x. 4 minus 2 is 2, and that would be your result. Alright, let's look at something that has just numbers, but also has what's called a rational. Now, rationals are essentially fraction exponents, and that's what we have here. So I have 7 to the negative 2/3 and then to the third. So one of the things that we have to do is we need to recognize what our rational is telling us in terms of your power. So this first one right here, or your numerator, is your power. Your denominator here is your root. Root meaning square root. So before we do anything, we have to rewrite our rational using the appropriate information. So this is the cubed root, so we're going to have the cubed root, and this is going to be 7 to the negative 2, and then the whole thing is cubed. Now the next thing we have to do is we have to look at this negative 2 here, which is the negative rule. So we're going to rewrite to say that I have the cubed root of 1 over 7 squared, and this whole thing is cubed. Now with that, I have cubed root and cubed, okay? So one of the things that we know is that when your root power matches the power it's being taken to. So this is my root power, this is the power I'm being taken to. When these match, the root goes away. So what I'm left with is 1 over 7 squared. Well, 1 over 7 squared is the same as 1 over 49. And that would be your end result for that problem. Now another thing that you need to know how to do is you need to know how to convert from rational exponents, or convert to a rational exponential notation, or basically turn a radical into a fractional exponent. So again, what that's going to come from is knowing what these mean. So the 8 right here is the root your 4 right here is your power. When we talk about a rational exponent, we always remember that it's power over root. And so here this would become x to the 4 over 8, but then you always want to reduce, which says that this is really going to become x to the 1/2, because 4 over 8 reduces to 1/2. Here, what we have to do is we have to do it to both of them. So what I have here is we have that the 4 right here is a root. This 5 right here is a root. Both of these have a power of 1. So here I have 9 to the 1/4. And I'm going to multiply that by 27 to the 1/5. Okay, so changing them over into exponential notation. We can also go backwards. We can take all these rational powers and we can rewrite them in terms of square roots. And so the first thing we need to do is we need to look at that piece by piece. So I have negative 12 over 16. So the first thing I would do is look at how does that reduce. So this is going to become a negative 3 on top and a 4 on bottom, because I can take a 4 out of both. Now, I want to go ahead and take a look here at both of these, and these are the negative rules. The other thing that I have here with my a terms, so this piece right in here, is I have the quotient rule. So the first thing we're going to look at is we're going to look at your quotient rule. So the quotient rule says that we're going to subtract up to the bigger term. So this is going to become a, and it's going to be 2/3 minus 5/8. And then both of these are going to flip their positions. So this is going to become b to the 6 over 7, and this is going to be b to the negative 3 over 4. So once we've done that, what we have to do is we have to finish the math that we have. And we also have to recognize that here we have another quotient rule. So we have negative 3 over 4. This is going to be a to the 1 over 24, and this is going to be b, oops, sorry, that's a plus, to the 6 over 7 minus 3 over 4. So again, I have negative 3 over 4, we have a to the 1 over 24, and we have b to the 3 over 28. Now again, we need to recall. So we need to recall the rule. And the rule says if I have a to the m over n, then what I have here is we have this top piece is your power, and the bottom piece, this piece here, is your root, or the power of your radical. So let's look at our problem here. We have negative 3 on top. And then here we're going to have the 24th root of a to the first power, and we are going to have the 28th root of b to the third power, and the whole thing is over 4. Alright, let's look at one more here. It should be enough to kind of get you started. So I have these two which are being combined. So the first thing I want to do is I want to kind of combine them. So this is really going to be 5 times 12, and then I'm going to have x to the 5 halves, x to the 4 thirds, y to the 1/3, y to the 7 fourths. 5 times 12 is 60, and then this is going to be x to the 5 halves plus 4 thirds, and then this is going to be y to the 1/3 plus 7/4. So you have to combine these using your fraction rules, and what you'll end up getting is you're going to have 60x to the 23/6, y to the 25/12. So now with this, we can write these as radicals. So we're going to have 60, and this is going to be the 6th root of x to the 23, and then we are going to have the 12th root of y to the 25th. Now we're not done because we have to reduce, and what you notice is that this is a 23, and the 6 here tells you how many groups you need to pull out. So this 6 here, this says that you are going to need a group of 6 identical numbers or terms. The 12 says the same thing, only instead of 6 you would need 12 identical numbers or terms. So one of the ways that you can do this easily is we can kind of create like a factor tree. So first we look at, does 6 go into 23 evenly? And the answer is no. So we would pull out an x, and this would leave us with 22 more. Does 6 go into 22 evenly? Well, no. So we would do it again. Siphon off another x and leaves us with 21. 6 does not go into 21 nicely, so do it again. Siphon off an x, leaves us with 20. 6 and 20 don't work, so again we can pull out another one and leaves us with 19, which doesn't work, so pull out another one and leaves us with 18. Well, 6 into 18 works. If we divide this by 6, we end up with 3. So what happens is that we can pull out x cubed, but then all these other ones left have to stay underneath the radical. So here, this 2, 3, 4, and 5 all remain. Okay? So what we have right now is we have 60. We've got an x cubed on the outside. I'm going to leave a space, and this is going to be my 6th root of x to the 5th, because I cannot pull a group of 6 out of only 5 remaining. Well, we can do that exact same idea with my y's. So let's go ahead and take a look at that. I have 12. So if I pull one y out, this leaves me with y to the 24th. Well, if I divide this by 12, I end up with 2. So this is the only one that's left inside. So what happens is I have y squared on the outside, and I have the 12th root of y left on the inside. And this would be the overall end result. Now the reason these don't combine is because their indexes are completely different. Okay? So there you have it. That should be enough to be able to get you started with doing some of this simplifying matters or refreshing yourself with exponents. Remember, these are only just one such approach that you can have to being able to solve your exponents. So please feel free to be creative, find your own approach, and as always, I'll see you next time.